Good morning, students. Happy Tuesday. So today, your guys' Go Formative is 3.05 Domain and Range, Day 1, Class Connect Participation. So I have it pulled up here. Go ahead and take a second to the warm-up. Which of the following symbols means there is an infinite number of possibilities for a number? If you chose the infinity symbol, you are correct. So some class notes for today. We're going to be identifying the domain and range. So as we've talked about before, domain is all real x values or the inputs that satisfy the equation. And then the range is all the y values or all the outputs that satisfy the equation. So when you're looking at these, when I talk about domain and range, I always go left to right. Okay, so if we look at this green right here, we can see it's looking left to right. So this arrow right here is going to continue going to the left. So if I continue going to the left on that x-axis, that's negative infinity. And then on this other side, there's an arrow that's going to continue going to the right, so that's positive infinity. And then your range is the exact same thing because it continues to go up and down. So negative infinity and positive infinity on that y-axis. Your x values for this parabola, you can see again, they're continue to go outward. So both going left and right forever. So that is all the x values. And then the y values, the lowest one we can have, so the, the bottom is -5 on that y-axis. And then there's arrows going up. So that would be positive infinity. And then you can see the opposite on this one. The x values are the same, but the y values are from negative infinity to 2 or less than 2. Okay, we can also represent these in interval notation. So that's what all of these are. So as long as there is no condition on the values we select for x and the domain and the range is generally all real numbers. There are two special cases, but all the diagonals will be the same way. So all linear functions, you're always going to have all real numbers because of the fact that they go left and right forever and up and down forever because they're a diagonal. So for all linear functions, you're going to have this same domain and range, except if you have a horizontal line. That'd be the only thing that's different. Here's another example. Here are the two special cases. So this is a vertical function, which is x equals 3. Okay, which again, that's not a function because it doesn't pass the vertical line test, but we can still determine it linear because it's a line. Where this one, x equals 3 is the domain, and then the range, since it's going up and down, is all real numbers. And then vice versa, this one is y equals 3. So it goes left and right forever, so it's all real numbers on the x value, but the y value is only going to be 3. Here's some more examples of functions. So here is again a line, which is infinity. They're both all real numbers. Here's one where it ends. So it's a linear function, but it's in a real life situation. So it's bounded. So if I look here from left to right on my x-axis, this is the furthest left side. So if I go down to my x-axis, that's at 0. And the furthest right on my x-axis is 8. So it'd be 0 to 8. And then on the y-axis, my lowest point is at 40 and the highest point is at 80. Okay, so again, you want to look for the lowest to the highest, make sure you're reading them that way always. And then here's another example of a horizontal function. We can also have a story problem where you're only looking at certain numbers. Okay, so here it says, suppose a gym changes registration of a fee to $50 plus $25 per month. Find the function of the total cost of joining the gym. So we can't pay 1.5 months, so you only have possible outcomes being 1, 2, 3, 4, 5, 6, and so on and so forth. And you're not going to be able to pay in half a month, typically. Which on the graph, it shouldn't actually have this line. They should just be the dots, because you only want those specific points. And then to find your outcomes, you would have to plug that into your equation. So let's practice this. It says, the first one says, what is the domain of the function? Okay, so again, you want to look left to right. So my furthest left on the point, or on this graph, is at -6. And then the furthest to the right is at +6. So for domain, always think left to right. So -6 to +6. Then for the range, that's your y values, or the lowest to the highest. That would be -3, which is down here. And then the highest point is up here at 7. So always bring it back to that y-axis, because your range is your y-axis. So that was -3 to 7. And always double check that they are in numerical order. The next one, domain again, left to right. So if I look at my graph, the blue part furthest to the left is at -6. And then if I go all the way to the right, the furthest right is at 5. It should be -6 to 5. Then lowest to highest, we want to find the lowest point. So the lowest point on my graph is here. So if I drag that over the y-axis, because we're looking at range, that's at -5. And then the highest point on my graph is up here. If I drag that over the y-axis, that's at 5. So -5 to 5. Okay, so that's how you do domain and range graphically. Hey, let's look at the next problem. It says a sandwich stand can make a maximum of 50 sandwiches per day based on the ingredient availability and labor time. The shop sells each sandwich for $5. Consider a model for the total revenue of the shop each day as a function of the number of sandwiches sold. Okay, so first says, what is the domain of the function referring to the context of the problem? Okay, so remember, domain is your x values or your independent variables. Okay, so out of the two variables, we have sandwiches and the revenue. Which one would be independent, or which one doesn't depend on the other one? And that would be sandwiches. Okay, because I can have a different number of sandwiches each day. So the set of all possible numbers of sandwiches that they can make or sell. Okay, it wouldn't be the prices, because the price is already set. That's the function. Okay, and it's not all the types of sandwiches, because we don't care what types of sandwiches. Then the range, the dependent variable, is the money we're making. Okay, the set of all the amounts of money the stand can make. So the sandwiches, how many sandwiches we make, depend or tells us how much money we're going to make. Then it says, complete the sentences. The domain of the function would span from the lowest value of blank to the largest value of blank. Okay, so remember, our domain is sandwiches. So the lowest number of sandwiches I can make is 0. And then they say the highest number of sandwiches that we can make is 50. So the lowest would be 0 and the highest would be 50. Then the lowest number of money we're going to make for the sandwiches, well, if I make 0 sandwiches, I'm going to make $0 during that day. And then we can make up to 50 sandwiches, and we know each of them is sold for $5. So if I take 50 times that $5, that gives us 250 would be the most money I can make during that day. Okay, and you could show your work during in that spot if you'd like. Okay, let's look at another story problem example. It says a storm hits New York, falling at a rate of 3 inches of snow per hour, or a total of 12 hours. Consider a function that models the total amount of accumulated snowfall in inches as a function of time in hours. So again, we want to identify the domain and range. So the independent variable here, so we've got snowfall and hours. So the independent variable is going to be time. Okay, I can't stop time. Okay, time is going to go on no matter what. So the set of all possible number of hours would be our domain. Okay, and we don't want the total number of hours because we want to make sure we're looking at all the possible hours. So we want to know what would the snowfall be if it only snowed for 5 hours, 6 hours, 3.5 hours, anywhere between. We'll talk about that domain in just a second. And the range would be the amount of snow that's accumulating. So the set of all possible accumulated inches in snow. So again, we want to complete this sentence. What is the smallest value for the snow or for the hours, and what's the largest value? Okay, so, well, it could not snow at all, so it could snow for 0 hours. And then the largest time it says it's going to snow for is 12 hours. So the range would be from 0 to 12. And it says the rate is from is 3 inches per hour. So if I'm looking at my snow, we would want 3 times our lowest number, which is 0, which gives us no snow at all. Okay, which makes sense because if it doesn't snow for any hours, you're not going to have any snow. Then we have a rate of 3 times, what if it snowed for all 12 hours? That would accumulate 36 inches of snow. So New York is going to get anywhere between 0 and 36 inches. The next example. Okay, it says, and Nellie is babysitting for the Sajet family who agreed to give $5 just for showing up to the house and an additional 8 hours per hours that she stays, for up to 10 hours. A function is written to model the amount of money as a function of the number of hours spent babysitting. Okay, so first we want to identify the the function, the domain and range. So here we're looking at the amount of money she's earned or the number of hours. So again, time will always be your independent variable. Okay, we cannot change time. So for the domain, it'd be the set of all possible hours that she can babysit for. And then the range would be the amount of money she gets, all the possibilities for the amount of money she can make. Okay, so not just the amount of money for showing up, but all of the possible amounts. And then we want to go ahead and find the lowest and smallest and largest values. Excuse me. For this, so first we need to find a function of her money. Okay, so we're looking at how much she earned. Okay, so that would be our Y value equals, and then it says she gets $5 for showing up, and then she gets $8 per hour. Okay, so remember that $5 is her base. So that's our B value. So that would be plus 5. And then our rate is that $8. So we would get 8 H, or you can put X. Okay, and if you wanted to, you could change that M to, or that Y to M if you'd like to have it as money. And then it asks you for the domain. So the lowest amount of hours she can work. Well, the lowest amount of hours she can work would be 0. And she can't work less than 0. And then it says they capped her amount of hours for 10 hours. And then the smallest amount of money she can make. So we want to plug in 0 into our function. So that'd be 8 times 0 plus 5. 0 times 8 is 0. Plus 5 would be $5. So she works, if she just shows up, she gets $5. And then if she works her maximum amount, that'd be 8 times 10, because that's the maximum amount of hours she can make, plus 5. So 8 times 10 would be 80, plus 5 would give you her $85, would be the maximum amount of money she can make. Okay, so I want you guys to go ahead and try this story problem on your own. So 15 through 15, 16, 17. And I also want you guys to try these ones on your own. So try all the way from 15 to 20 on your own, and I will give you guys some feedback on that. And go ahead and fill your exit ticket out when you have finished. And here are some more practice problems if you need some more help. Your guys' homework for the night is, you guys don't have any homework for the night, so this right here will be your independent practice, those breakout room problems. So make sure that you guys submit those so that I can give you some feedback today. Have a great day, and I will see you guys tomorrow through video.